This presentation reviews LASSO Regression. IM and Avatar was organized by Dr. Alemi and Dr. Hafiz. The purpose of LASSO Regression is to select a minimum set of variables that would explain most of the variance in the response variable. In an ordinary regression, you regress the dependent variable y on a set of independent variables x1 through xn. I is the output or the variable we want to predict. x1, x2, xn are the features. b0, b1, b2 are the coefficient weights estimated from the data. LASSO regression minimizes the sum of the coefficients, forcing many variables to have zero coefficient. L1 is the sum of the absolute value of the coefficients multiplied by a tuning parameters, i.e. lambda. Here we see that with lambda 0, the regression includes x2, but with lambda 1, then x2 drops out. Larger lambda gives us fewer variables selected. Smaller lambda allows us to pick up more variables. Ordinary regression is minimizing the sum of squares of residuals. In LASSO, we add the regularized term to minimize the number of features allowed. When lambda is 0, LASSO is the same as ordinary multiple regression. To get an intuition about LASSO, let us look at an ordinary regression with one variable. Here we see that the fit between the regression equation and x is not very good. The line is linear, but the data are not. We can add in more variables by taking x to different powers. With 5 variables, we can perfectly fit the data, but we are modeling noise. This kind of error occurs when the number of cases is less than number of features. LASSO can help us model the data with fewer variables and thus avoid overfitting. LASSO drops x to power 3, x to power 4, and x to power 5. It only keeps x and x to power of 2. It selects a set of feature that does not do overfitting and can explain most of the data. So what does LASSO do for us? It helps us select a set of direct predictors of y. The ignored variables can still be correlated to y, but not when the selected variables are present. LASSO keeps only the direct predictors of y. These direct predictors, also called non-zero predictors, make all other variables irrelevant. Recent work has shown that we can use LASSO to organize a network. First, we look at outcome y. Find all of its direct predictors. Here we see that x1 through xp are the direct predictors of y. The predictor of direct predictors of y are called indirect predictors of y. Here we see that xr and x's are predictors of xp, which itself is a predictor of y. Indirect predictors are associated with y only when the mediating direct predictor is not present. LASSO and the temporal order of variables can tell us a great deal about what associations matter and correlations can be ignored. It identifies direct predictors and ignores indirect associations. Thus, it tells what correlations can be ignored. LASSO uncomplicates our lives by selecting direct associations and ignoring many other associations in the data.